For week number 14, we have to discuss chapters 11.1, 2, 3, and 4. So we start with the introduction to linear regression. Introduction to linear regression. In statistics, linear regression is a linear approach to modeling the relationship between a scalar response and one or more explanatory variables. The case of one explanatory variable is called a simple linear regression. Regression analysis is used when there is a relationship between two random variables, and when this relationship may be expressed in the form y is equal to beta 0 plus beta 1x. Have you ever seen what is this? This is a straight line, isn't it? Y is equal to mx plus c. You might have seen y is equal to mx plus c, where m is the slope and c is the y-intercept. This is what given here. So this y-intercept is given first and then slope. Okay. This is the degree increasing degree of this equation is in the increasing degree of x. Here x power 0, here x power 1. If there is any other variable, it will be beta 2x square in this order, right? So beta 0 is the y-intercept and beta 1 is the slope. So expressing the data as a straight line, that we are going to draw a straight line which is most closer to the given data. When you draw the scattered graph of the data and you draw the straight line representing the data, the line will be the closest possible line to all the data points. This is our linear regression model, right? Here y is the dependent variable which depends upon the value of x, which is called independent random variable, right? The arrow of example has been shown here. This is the model. Y is equal to beta 0 plus beta 1x. Beta 0 is the y distance. So when all the data are drawn here as a scatter graph, a dot plot, and then we will finally find a straight line that will be most fitting to the data. This line will be closer to all the data in the data set. We use regression analysis when the relationship between x and y is not deterministic. In other words, the relationship does not make perfect predictions, but it hopefully has some measure of reliability in its predictions. We will use this one to predict the value of y for some values of x, which are falling in the given data set. The concept of regression analysis deals with finding the best relationship between y and x, quantifying the strength of that relationship, and using methods that allow for prediction of the response value given values of the regressor x. X is given, you can find y, right? Now 11.2 simple linear regression model. We wish to estimate the parameters beta 0 and beta 1, which we call the regression coefficients. We call these two as regression coefficients, and our aim is to find these two. If you know beta 0 and beta 1, you are done with the straight line, isn't it? Our fitted regression line is given. This is our regression line. Here y cap is predicted value with the random variable capital Y for the value of x of the random variable capital X. Capital X and capital Y stand for random variables. Y cap and small x stand for the values of the random variables. Of example has been given here. The college bookstore must order books 2 months before each semester starts, right? They believe that the number of books that will ultimately be sold for any particular course is related to the number of students registered for the course when the books are ordered. they would like to develop a linear regression equation to help plan how many books to order. From past records, the bookstore obtains the number of students registered as X and the number of books actually sold up for the course Y. For 12 different semesters, the data has been shown below. This is the data. For first semester, number of students registered, this is X and this is Y. This column, books column is Y. Now, we are not solving this one. This is a book example or a trial example given to you. You can try this one. After I explained how to solve this one, you can try this problem. Okay. What I am going to say here is this number of students registered is given as number of students registered as X. This is Y, isn't it? This is the information for X and this is Y. So using this information, we are going to draw a straight line which is Y is equal to B0 plus B1 X. Okay. How to find this B0, B1? The formulas are coming the next probably the next chapter. Yeah. And so the regression has been found. Here B0 is 9.3, B1 is 6.673x. So when you draw this one on the graph, the straight line looks like this one. You can easily draw, give some value, x is 0 will give you y value. Here you can find y intercept. X is 38, give x is 38, that will give the end point of this line. So just connect them, you will get the straight line on the graph. Now the dots are the data given here. Against 26 students, what is the number of books? You can check 26 students, 26 books will be there. The data set. See here in the last row. 26 students, 26 books. So all the data have been arranged in ascending order, and the dot plot plot has been drawn. Scatter graph, you can say. And now this is the possibly this is the line that is very closer to all the data possible in the given, right? So this is what we are going to do in this chapter. We will find the line that is most fitting to all the data, so that if you miss any value, if you want to calculate the y value for 33, you can calculate by using this y. It will be very near to the group data numbers. Fine. Distance, least square and the fitted model. In this section, we discuss the method of fitting an estimated regression line to the data. This is tantamount to the determination of estimates beta 0 for B0 for beta 0, B1 for beta 1. Okay. This is of course allows for the computation of predicted values from the fitted line y cap is equal to beta 0 plus beta 1x, and other types of analysis and diagnosis information that will ascertain the strength of the relationship and the adequacy of the fitted model. We'll see in examples, right? Before we discuss the method of least square estimation, it is important to introduce the concept of residual. What is residual? We are going to discuss. Residual is essentially an error in the fit of the model. So it's not error free. There are errors, isn't it? So y cap is equal to in this model y cap is equal to beta 0 plus beta 1 x, isn't it? So residual is an essentially an error in the fit of the model given here. So the formula is given here for residual error in fit. You got a set of values xi, yi. So x1, x2, x3. You can say from the previous data there are 12 some data for x and yi. All the pairs we collect x1, y1, x2, y2. And the fitted model. This is the y cap values for every xi. I will solve this one. In an example, we will certainly find residuals, and that at that moment we will come back and discuss what is this one, right? So residual is the actual difference between yi and y cap I. Ith value of y in the column and the corresponding y cap I calculated from the straight line for the corresponding xi value. Okay. What is this? We will discuss an example in coming pages. Obviously, if a set of n residues is large, then the fit of the model is not good. Small residuals are a sign of good fit. Another interesting relationship which is useful at times is the following. So this one, y I cap beta 0 plus beta 1 xi plus residual. Ei is the notation of residual. Our job is to find the values of b0 and b1 which give the best line which is closest simultaneously to all the points in the dataset. Estimating regression coefficient. This is the actual formula we are going to use to find the values of b0 and b1. Don't be scared when you see the formula. This is not new to you guys. b1 I will write in simple form. b1, this one is nothing but n times summation xy minus summation x summation y, multiply this one, divided by n times summation x square minus summation x whole square. What are all these things? Assume that just I'll give you three data: x, y. X is 3, 2, 5. Y is 8, 6, 7. Okay. Now x square, I write this side. X square is 9, 4, 24. Multiply x and y. X, y is here. X and y, 3 into 8, 24, 2 into 6, 12, 5 into 7, 35. Now this column, when you sum this column of x square, this is called a summation x square. When you sum this column elements, x column elements, it is called a summation x. When you sum the y column elements, called a summation x, summation y, sigma y you can call. And all these elements, 24, 12, 35. When you sum them up, it will be giving you summation xy. Now I think you got all the elements. Summation xy is given here, summation x, summation y, isn't it? Summation x square is given here, summation x again here. N is the number of elements of the data, number of pairs, how many? X is 3, y is 3, n is 3. So when you use this information in this formula, you will get the b1. You got an idea? So the x and y will be given to you. You will find x square, you will find x into y. And find the total of every column. Okay, that will give you the terms we need to find b1. Now what is b0? b0, see, remember the line, y is equal to y cap is equal to b0 plus b1x. So if you know you want b0, it will be y minus b1x. The formula is looking like y minus b, is not y actually, y bar, the average of y, the average of x. So from this equation of statement, it looks like we can find b0, but it's not y here. It's y bar and y bar. So we are tied y bar is equal to b0 plus b1 x bar. That will give you the formula for b0. So what is y bar? Summation y over n, average of all, sum of all the data in y and divided by n. b1 is calculated here in the previous step, b1. X bar is summation x over n. That is what given here. N is common. This is summation y, summation x, all divided by n. Okay, that's another formula to find that's another constant of b0. Once you find b0 and b1, we can directly write the most fitting regression line y is equal to b0 plus b1x. Once this information is ready, you can give any value for x to predict the value of y. That is the purpose. You can find y for the unknown, for the value of for the new value of x, which is not in the given x list. You can forecast what is y. Okay, that's the purpose of learning this regression lines. Okay. Now this is our first example. I would like to move to the white sheet. I see. Let me give you the white page. Remember this problem, and I am going to write it on. See what we got to find here. Estimate the linear regression line. So we are going to draw the linear regression line. We are not drawing. We will find the equation of the line. Estimate the final approximation. Final approximation. What is x and what is y? X is the grades of a class of 9 students. So n is 9. N is 9. Midterm report x. Midterm report x. And on the final examination y. X stands for midterm values. Y is final exam values. Isn't it? So estimate the final exam grade. Estimate finally you have to find the y for a student who received a grade of 85 on the midterm. See, 85 is not available in the X list, but 85 is certainly in the range of 85. The minimum value of X is 71, 67, and the max, no, there is 50 as well. Okay, X value starts from 50 and ends at 99. Within this range or to the in the neighborhood of x, this value 85 is taken. It's not far away. Remember that this 85 is not far away from the list of x. Yeah, if you take x is 500 or negative 83, it will be far away from this x group. So while you forecast the value of y, you should make sure that the x value is not far away from the data. So we will find these two on a separate sheet. Let me write down the data here. X X column and Y column. X column is 77, 50, 71, 72, 81. There are 9 numbers. So n is equal to, remember in this problem, n is equal to 9. 9 students are there. 81, 94, 96, 99, and 67. Yes, Y values 82, 66, 78, 34, 47, 85, 99, again 99, 68. Sum the values of x. This is summation x, which is equal to 707. And here, sum the values of all this y. Summation y is 658. Okay. So let's roughly draw a line to separate this x. Now, what do you mean by xi? Xi, when I say xi, and I varies from 1 to 9. X1 is 77, X2 is 50, X3 is 71, X4 is, this is the way, isn't it? So does the y. Now, B1, we have the formula for B1. We are going to find y is equal to B0 plus B1x. We are going to find this line, regression line, isn't it? We can write y is equal to B0. What is B0? What is B1? The formula of B1 says n times summation xy minus summation x into summation y, summation y divided by n times summation x square minus summation x whole square. We want x square. I'll find x square to the left of x. I'll find xy to the right of this one. Okay, let's do it. For one problem, I'll show all the steps, and then second problem I'll more. Okay. Now x square 77 square, which is 5929. 50 square 2500. 71 square 5041. 72 square 5184. Use your calculator to find it. 81 square 6561. 94 square 8836. 96 square 9216. 99 square 9801. 67 square 4489. And when you sum all those things, you call it summation x square, which is 57557. 57,557. Okay, that's what we need for this term, summation x square. N is known, 9. We know summation x, we know summation y, we know summation x again. We want one more term, summation xy. Xy, multiply x and y. 77 into 82. 6314. 50 into 66. 3300. 71 into 78. 5538. 72 into 34. 2448. 81 into 47. 3807. 7990. 9504. 9801. 4556. Now when you sum all those things, we call it summation xy, which is equal to 53,258. Almost done, isn't it? Now find b1. Substitute all the values here. 9 times 53,258. This is our summation xy minus summation x. Here it is 707. 707 into summation y 658 divided by 9 times summation x square in the first column 57,557 minus summation x whole square 707 whole square. Use your calculator. The answer will be b1 is 0.7771. 3 sevens followed by 1. That's b1. Okay. Now one more constant remains to be found, b0. Now the formula of b0 is, we know b0 is y bar minus b1 x bar, average, isn't it? That is y bar summation y over n minus b1 summation x over n, so n is in common. What is summation y is given here. Summation y 658 minus b1 is given here and here b1 0.771 times summation x, which is given here 707 4 divided by 9. That will give you b0 is equal to 12.0623. Now we are drawing the regression line. We are writing the equation of the regression line. Y is equal to b0 plus b1x. So y is equal to b0 12.0623 plus b1 0.7771 times x. This is our answer for the case number 1. Case 2 wants us to estimate the y value when x is equal to 85. So when this is case B. So when x is 85, y is equal to 12.0623 plus 0.7771 times 85. Calculate this one. Instead of x, we use the value of 85. Therefore, y, the predicted, the forecasted value will be 78. When x is 85, then y will be 78. So if the student misses the final exam, but we know his midterm exam is 85, by using the regression line, regression line represents the line that is closer to the marks of the class, isn't it? So we can predict his final exam value by this one. That is drastic, isn't it? His 85 is scored in midterm, but by forecasting you get 78. So there are some errors actually. The errors are here residuals. We are going to find residuals. How do you find residual actually? There is a problem though, and we will discuss it in that problem. Okay, that's the end of this problem. Let me check what's the next problem. That's been solved here. Next problem. The amounts of a chemical compound Y is chemical compound in grams, right? Dissolved in 100 grams of water at various temperatures. X is given as temperature. Were recorded as follows. Okay, here we see different. Find the equation of the regression line. So first we will find regression line just like this problem, and graph the line on the scatter diagram. First we will draw the scatter diagram of the data, and then we will try to fit the line to the data. And estimate amount of chemical, estimate Y when X is 50. The additional information in this problem is to draw the line on the scatter diagram. So we have to draw the scatter diagram, then draw the line. Okay. Here, see, there are 18 information for Y, only 6 information for X. So you should write this one as X. There are 3 0 values for Y. For first 0, you'll get 8. Second 0 is 6. Third 0 is 8. Now 15, 15, 15, you should write 12, 10, 14. Okay. Other X values are 30, 30, 30. Y values are 25, 21, 24. Here it is 45, 45, 45. 31, 33, 28. Again, totally n is see 3, there are 3 6s, 18. N is 18 in this problem. X and Y will have 18 values. Another X after 45, this 60, 60, 60. What is Y value for that? 44, 39, 42. And finally 75, 75, 75. That is 48, 51, 44. Now we collected all X and Y values. Sum all the X values. Sum all the x values. What we get is summation x 6, 7, 5. And now take all y values. Sum them up by using your calculator. All y values, summation y is equal to 488. Now find x square. X square, another column. 0, 0, 0, 15 square, 225, 225, 25, 900. So find all x square and sum them up. Summation x square. Summation x square is 37,125. Next, for every x and y, multiply x and y. Write a column for xy. This is 0, 0, 0. First three terms are 0, and then multiply 15 into 12, 15 into 10, 15 into 14, and all xy. Summation of all xy. X times y. Find xy for every pair, and then what? Sum them up. That is summation xy, which is 25,005. Now using this information, we can find B1. B1 n times summation xy minus summation x summation y divided by n times summation x square minus summation x whole square. So B1 is n times xy. N is 18. N is 18. Summation xy is given here. 25,005 minus summation x is 675 and summation y is 488 divided by 18 times summation x square. What is summation x square here? 37,125 minus summation x whole square. 675 whole square. So use calculator. The answer is 0.5676. So now I erase this table. So what you get is, B1 is 0.5676. The formula for B0 is summation y minus B1 times summation x divided by n. Summation y from the table, it was 488 minus B1 is here. B1 0.5676 times summation x from the table, it is 675 divided by 18. Now use calculator to find the answer. The answer is the answer for B0 is 5.8254. So we got both B0 and B1. Therefore, the answer for A, the regression line y is equal to B0 5.8254 plus 0.5676 times x. This is the regression line. Now I'm solving C, then we will go for scatter graph. C. When x is equal to 50, what is y? The 50 is in this range, so 0 to 75, the temperature is varying. So 50 is not far away from that, it's in the group. Y is equal to 5.8254 plus 0.5676 times 50. Therefore, y is equal to 34.205 grams. That is the answer for case C. Now let us think of the scatter graph for the data. Okay, scatter graph. Then we will draw this line on this line. Equation number 1. Okay. So how to draw this line on the xy plane? Give x equal to 0, you will get to y-intercept, isn't it? And give x to the maximum value in the data. You will get another value for y. Connect them by using your measures. Okay. Okay. Oh, I roughly draw here the scatter graph. We will take this is y-axis and this is x-axis. On the x-axis, I take this is 10, 20, 30, and it will take March 40, 50, 60, 70. Okay, but x has 75 values. Degree maximum is 75. 0 is here. Okay, and the data values are between between 50 now. There is nothing more than 50. 44, 48, 51. Maximum is 51. Minimum values are 6 and 8. That's it. Okay, we can take this one on 10 scale. 10, 20, 30, 40, 50. So for 0, when x is 0, there are 3 values of y. One is very near to 5, 6, isn't it? And then near to 10, 8. There are 2 data for 8. So 6 and 8. This is the dot you get. And now for 15, there will be 15. X values are 15, 30, 45, 60, 75. These are the x values. Against the x value, we are going to find the dots for y. Y is 12 here. 12, 10, 14. So 10 against this 15. This is represented. This dot represents 10, 12, 14. Isn't it? Not far away. 14 is between very near to 15. Okay. For now, x is 30. We need to come around 21, 21, 24, 25. Similarly, for 45, x is 45. Or 31, this is roughly I'm drawing. You can use SPSS to scatter it. 31, 33, 28. For every x value, there are 3 y values. Next, x is 60. You gotta go to 40. Near to 40. Again, 40. There is 44. 39 is one data. And then 42 and 44. Finally, for x is 75. 48. It could have been a little bit more. 50 here. 48 near to 50. 51. And the one is where is this is 51 and this is 44. Somewhat roughly I have plotted the data, isn't it? It's going this way. Now how to fit the data, how to fit the straight line. When x is 0 from the straight line, actually what is the straight line? Y is equal to 5.8254 plus 0.5676 times x. When x is 0, y is 5.8254. I want to give the maximum value for x to get another end of y. So y is something 5.8, very near to 6. In the y-axis, when x is 0, you are on the y-axis, you are here near to 6. This is our point, the first point of the straight line. When x is 75, give the end value for x. What is y? Calculate it from here. Give x 75. We'll find y is equal to 48.40. Around 48. 48 is somewhere here. For x is 75. We will find a point near to 50 here, isn't it? So we have to join these two lines by using a proper scale, right? This is our scatter plot and regression line. This is our regression line for y is equal to b1, b0 plus b1x. And the data are very close. This is the line that is possibly closer to all the data. That's done. We are done with the problem. Next problem is the solutions are here. You can check. Problem number 3. A study was made on the amount of the converted sugar in a certain process at various temperatures. The data were coded and recorded as follows. So this temperature is our x, converted sugar is y. Okay. So we will find the summation y here. The summation y for this problem is 100, 100.4, and summation x. This is summation y. Summation x here, sum of all the x values. 16.5. Now find here x square 1, isn't it? And all the squares 1.11, 1.21. You can find all the squares by using calculator. And the sum of all the squares I'm writing here. Sum of all the squares, x squares. 25.85. Now multiply x and y here. This column x and y, multiply 1 times 8.1 and then multiply all the data by using calculator. Summation of x, sum all the elements. You will find 152.59. Okay. Now using these values in B1, you will find the data is 11. N is 11. So 11 times summation xy 152.29 minus summation x 16.5 times 100.4 divided by 11 times summation x square 25.85 minus summation x whole square 16.5 whole square. When you use calculator, you'll find B1 is 1.8091. Now the formula for B0 is summation y minus B1 summation x whole divided by n. Summation y 100 0.4 minus B1, 1.8091 times summation x. Summation x is 16.5 divided by 11. So B0 is 6.4136. So we got the line. The line y is equal to B0 6.4136 plus B1. B1 is 1.8091 times x. So give the value of x here, and the temperature is 1.75. This is A. For B, just give x value here. This x value is 1.75. Then you will find y value is equal to 9.580. Substitute the x value as 1.75 in this regression line. You will get y is 9.580. We are done with A and B. The question is what is A and B has been done. The question is C. Plot the residuals versus temperature. What is residual? Well, we have to recall the definition of residual. I'll go to a separate sheet now. I'm going to draw the residual for this one. Okay. Remember, residual formula I'm writing. The formula for residuals is EI, which is yi minus y cap I. What is y cap? Y cap and I varies from 1 to here. There are 11 data. What is y cap I? Here our regression line. Y cap, isn't it? Y cap is, I write y cap is 6.4136 plus 1.8091 x. So for every xi, you will get y cap I. And you remember what is y I are given in the table. So xi, the problem given us 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2.0, isn't it? And yi also given in the problem. Yi 8.1, 7.8, 8.5, 9.8, 9.5, 8.9, 8.6, 10.2, 9.3, 9.2, 10. These are given information. We are going to find yi cap. Then the difference between this term and this term is our residual. So what is yi cap? Substitute x is I in the first formula. This formula, the regression line will give you yi cap, right? So xi, the value of xi is 1. Substitute this value here, that is 6.4136 plus 1.8091 times 1.0 xi. So what is your y cap? First answer is 8 point, so it's 8.2227. Second, so this is your given information. X is here, y is here. Now we are finding yi cap, the yi values, the forecasted values for x. This is the given original values, but when you forecast the value by using x, what is the value and what is the difference between them? What is the error, residual, isn't it? That is going to be here ei, which is yi minus yi cap. This one 8.1 minus 8.22 is negative 0.1227. You understand? This is EI. Okay, residuals. Okay. Now we will do it for all the times. And now we have to plot the dot graph that against temperature we have to plot the residuals. Again, second one here, again repeat this one, 6.4136 plus 1.8091. Here x value is 1.1. So what you get is 8.40361. Repeat this one. Repeat this one. Here x value will be 1.2. Therefore 8.58452. Repeat this. X value is 1.3. You will get 8.76543. For x value 1.4, you will get 8.94634. For x value 1.5, you will get 9.12725. Then x is 1.6, you will find 9.30816. For x value 1.7, 1.7, the answer will be 9.48907. 1.8, 9.66998. So for x value 1.9, it will be 9.85089. For 10.5, x value 10.5, you will get 10.0318. That's yi cap. Now this minus this one, you get here negative 0.60361, and this minus this one. This is bigger. Now you'll get positive value. Positive value. Now yi actually yi minus y cap. This minus this one, and yi minus y cap yi cap. So this minus this one again negative. 0.08452. But here it is bigger, 9.8, here 8.7. So you'll get positive to 1.03457. Next, we have to do this for all the 11 elements. 9.5 is bigger than 8.9. See, now we'll get to positive 0.55368. And from this one, 8.9 minus this term minus 0.22725. These are all the residuals. In this column we are finding residuals, right? Now 8.6 minus this one, again first number is smaller, so negative 0.70816, and 10 minus 10.2 minus 9.4, this one, so positive 7.0. Positive 0.71093. And from this data, what if 9.3 minus some will be negative 0.6589. And from this data, 9.2 minus 9.85. Okay, sorry, small error. Here the value might have been this one, and when you subtract 966 from 9.3, you will get negative 0.3 36998. Here I get negative 0.6589. Finally, this will be positive 0.4682. So there are some positive values and some negative values. Now draw the residual versus temperature. Temperature is x, okay? X is from 1 to 2. 0.1 is the scale. And we are going to draw the residual. Residuals versus temperature. Okay, I draw this one. Guys, it's a rough graph. Okay, don't expect me to draw exactly. Okay, I can try. Let me use the scale. I'm going to do troubles. Okay, let me use another option. No. Okay, by hand let me try. Here I'm going to write the x values. X value starts from 1, isn't it? 1. Next I take 1. This is 1.0, 1.2, 1.4. You can take 1.1, 1.2, but in the order, no problem. I taken 2 units, say 1.8, 2.0. So here you'll find 1.1. Here you'll find 1.3. Here you'll find 1.5, 1.7 here, 1.9 here. Now data. The residuals. If you go through the residuals, the minimum most value will be. The minimum most value will be, what is it, 0.08 or 0.08. Negative is there, so it will be negative 0.7 between negative 1 and positive 1. Okay, I can roughly draw here. So I take the middle value as 0. This side it is negative 0.5. Here it is negative 1. So I can take here is positive 0.5. Is positive 1.0, right? Negative 1.0 equals to 1.0. Now just find the dots against that one. X is 1. X is 1.0. What is it? When x is 1.0, the residual is negative 0.122. Very close to 0. 0.1, negative 0.1 is very close to 0. So first residual, I'm going to mark the residuals by using. Okay, let me draw some lines to represent this. This is representing -1 level. This is -5 level. This is 0 level. This is 0.5. This is positive 1. Now let me find the dots. Very near to 0 for 1. When x is 1.0, this is very near to 1. There is a dot. Very near to 0, but in the negative direction. Okay. When x is 1.1, What is residual? Negative 0.6. Negative, little bit lower than the negative point, negative 0.5. This is negative 0.5. It will be moving towards negative 1. So here 1.1x, then it find a dot here. Is it clear now how we do? This is the scatter graph for the residuals versus temperature. And now you understand what is residual. Residual is the difference, actual difference between the original y values and the forecasted y values. Okay? Forecasted, predicted value by using the line. So, for example, if your forecasted final exam marks based on your midterm mark is 75, but your actual score is more than 80, the difference is residuals here, right? Fine. Now, third one, we have to fill in for 11 elements. Third one, 1.2, when x is 1.2, it is negative 0.8. Negative and close to 0, lesser than, very close to 0, isn't it? Closer than this point. So 1.2, when x is 1.2, this will be more close. More closer, there should be a point when x is 1.2, there will be more closer but lesser than, that is negative sign, negative sign 0.0. Next, when x is 1.3, it is fourth value. When x is 1.3, is 1 point more than positive 1, more than positive 1, 1.0347. So when x is 1.3, it goes here more than 1. Now for x is 1.4, x is 1.4, come here, 0.55, positive 0.55, near to positive 0.5, which is above 0.5, isn't it? 0.55. You'll find for x is 1.4, this is positive, very close, 0.55. And for 1.5, when x is 1.5, it is negative 0.22, negative 0.22, negative 0.2 is between 0 and negative 5, negative 0.5. So 1.5, when x is 1.5, it is 2 units down the 0, down to the 0, it will be here. 1.6 will give you negative 70. So negative 7 is 5 point, and negative 5 here, negative 7 will be here. 1.7 will give you positive 7 1. 1.7 will give you positive 7 1. So 0.5 plus 2 units are 1.8 will give you negative 0.3698. Negative 0.36 will be here. 1.9 will give you negative 0.65. Okay, this is negative 2, 2. We should run this one here. Negative 2, 2. Okay, to 1.5. will write from 2 is 0.46 positive, very near to this one. For 1.9 negative 0.6, it is here. 1.8 is negative 3, negative 0.3. It will be here. For 1.9, 1.7, positive 0.0. This is right. Okay. 1.6. It will be negative 0.7. Negative 0.7 will be here. That's right. So this is the scatter graph for residual versus temperature. That is the end of this problem. Okay. Thank you very much. And let's see any other problem for me. Okay. The scatter graph computer generated has been given here in the problem. And now last topic, 11 last topic for this week. 11.4 properties of the least square estimators. The least square estimators for beta 0 and beta 1 are both unbiased estimators. Actually, this is our error, yi minus y bar, what we have is called residual. This is our residual. Residual square divided by n minus 2. When you sum them up, you get s square sample variance. So, which is an unbiased estimator of sigma square. We have seen in the beginning that sample variance is an unbiased estimator of sigma square. So, that is the property here. So, by using the residuals, we can find the population variance. That's the property here. And this will be for next week. Thank you very much.